Good afternoon, guys. Mr. Verga here, coming at you again from Math Land. Today we are taking a look at Module 2, Task 5. So we're 2.5 in your book. And I just wanted to make a video for you guys. If you would take a look at page 25, we're going to look at some quadrilaterals and seeing what kind of things we can say about these quadrilaterals based only on the congruent triangles that we might find inside. So hopefully you guys have had about 20 minutes or so to work on this, and I'm going to start when it says that you need to pick one of the following quadrilaterals to explore. So I'm going to do all three of these just so that everybody, no matter what you picked, you get an idea of what's going on. And I'm going to start with a rectangle. So it gives you the definition. A rectangle is a quadrilateral that contains 4 right angles. Okay, so if we start, I've got my handy dandy straight edge. I'm just going to start by drawing my rectangle. And I don't want to make it too big. Good. Now, to make this properly a rectangle, I'm going to use my protractor to make a 90-degree angle. So just to remind you, the middle of my protractor is going to go right on the edge of the angle that I'm trying to make. I'm going to line up one side with the 0 and then make a mark at 90 degrees. That tells me that this mark is 90 degrees from this line. So if I take my straight edge now, I know that this angle that I made is 90 degrees. And we can make it just to right there because this is a rectangle, so not all 4 sides have to be equal. So we're going to do the same thing over here. Remember, the center of my protractor goes on the vertex of the angle I'm trying to make. 90 degrees right there. And I'll give you a little hint. The reason I kept it this side as long as I did was because I knew that it was just to this mark that I had made at the top of my protractor. So if I do the same thing now, I know that this side is going to be more or less the same length because they're both measured to the top of my protractor. So, little life hack for you. Finally, just going to close up this rectangle now. And there I go. Boom. Now, this is a rectangle, which means I know that all 4 of these angles measure 90 degrees. Cool. Oh, let me focus that camera up for you. Boom. There we go. So we've got all 4 of these angles. They measure to 90 degrees in my rectangle. And then let's go on to number 1. It says label the vertices of the quadrilateral A, B, C, and D. Awesome. And it says label the point of intersection of the 2 diagonals as point N. So I'm going to grab my straight edge one more time. I'm going to draw my diagonals in. All right. And I'll give you a little tip. If you put your pen on your point and then bring your straight edge up to it, you can eliminate any of that guesswork for your pen. Labeling the point in the middle here as point N, and we're good to go. All right, cool. So going on to number 2 now, it says based on your drawing and the given definition of your quadrilateral and the information about sides and angles that you gather based on lines of reflection and rotation of symmetry, list as many pairs of congruent triangles as you can. So what can we say about this rectangle? Now, we know that this side, AB, is going to be congruent to this side, DC. Now, how do we know that? Well, from our last video, if I put a piece of paper, or in my case, a transparency over this, and I trace out this triangle right here, here we go, and some of you may see where I'm going with this already. I can tell you that by rotating this around 180 degrees, it lands on that triangle right there. So that tells me that these 2 triangles, A, B, N, and DCN are congruent, which means that all their corresponding parts are congruent. So AB is the corresponding part to CD because AB lands on CD when I rotate. Okay, now BN, when I rotated this, where did BN land? That's right, it landed on DN. So that means that BN and DN are congruent. And finally, AN, when I did my rotation, landed on CN. And so we're going to say that those are corresponding parts, so they are also congruent. Okay, cool. So that tells me that this triangle ABN and this triangle DCN are congruent, and we can list that out right here. So triangle ABN is congruent to triangle DCN. Awesome. Do you see any other two pairs of triangles that are congruent? Yeah, definitely. Now I'm going to use a different color to mark these since we've got blue for the other ones. So we can see that this triangle BNC, this bigger one, is congruent to triangle DNA. And again, if I were to rotate this triangle down here, we would see that BC would perfectly line up with DA, so we can say that those guys are congruent. We can say, all right, since BN is going to rotate to DN, right, we know that they're going to be congruent, but we knew that already. So I'm going to leave those marks there. And then CN, if I rotate this one, is going to line up with AN, and of course that makes them congruent, but we know that already too. And so these two triangles are congruent, so I can write that this triangle BNC is congruent to this triangle DNA. And there we go. Does anybody see any other pairs of triangles that are congruent? Look harder. What about this big right triangle ACD? If I took this big triangle ACD and I rotated it around the center, all right, let's get my transparency to do that. So if I took this triangle, and I know there's probably a glare, so bear with me. If I took this triangle ACD, and rotated it around 180 degrees, check that out. It lands on this triangle ABC. So we can say that those two are congruent. Remember, because a rotation is a rigid transformation, it maintains size and shape, which is congruent. So ACD, this big triangle, is congruent to ABC, this other big triangle. All right, and similarly, this big triangle ABD is congruent to this big triangle up here. All right, I did ABD, so I'm looking at CDB. This one here. All right, I think that's all the pairs of triangles that we've got. So let's talk about why these are congruent triangles outside of our transformations, right? So what about these would be a good criteria for congruent triangles in number 3? So for example, ABN congruent to DCN. This guy right here, ABN congruent to DCN. Why are they congruent? Well, we found out that these three sides are congruent, right? But what's something else that we know? Well, we can say that these angles in here are also congruent angles, and that's because there's something called vertical angles. They're across an intersection from each other, and that's going to be true anytime two lines cross. The angles across from them are called vertical angles. Vertical angles are congruent. So I could also use side, angle, side. and side, angle, side. Similarly with these two triangles here, and I'm going to go ahead and label these triangles. So that's triangle 1, this is going to be triangle 2, this is going to be triangle 3, and this is going to be triangle 4 for ease. So triangle 1 and triangle 3 are congruent by side, 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 or by side, angle, side. Triangle 2 and triangle 4 are congruent by side, 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 or by, again, side, angle, side, because that has the same side, angle, side corresponding parts. And now what about these big guys right here? Well, I could use the same thing, right? Side, angle, side, side, angle, side. Or side, 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 and side, 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 right? All right, so that's a rectangle. What if I wanted to do this for the next shape suggested, a rhombus? So doing this for a rhombus now, I'm gonna make my